Hi, it's Jan Beta, and today I am going to build a pretty nice and very old school Autofire circuit for my self-made joystick. I searched all of the internet for suitable Autofire circuits, and there's a lot. I considered using something that's based on a modern Arduino kind of part or a microcontroller, but I found this at Forum 64, which is, in case you don't know, the largest Commodore 64 German language forum around. Highly recommend that. There's also, most people also understand at least English, so there's also English threads from time to time. Actually, somebody, Captain Future, posted a slightly modified version of an Autofire circuit from the 64er magazine, which is the most popular, or it was the most popular Commodore-focused computer magazine in Germany. They published like hardware modifications of all kinds for your Commodore 64 or other Commodore computers. And one of those was the Autofire circuit, which then got modified by Captain Future, who is Frank in real life. And that's the circuit I actually want to build. It's based on a 555 timer chip, because basically what Autofire does is to pull down the signal periodically. Basically it generates a square wave, and 555 timers are kind of ideal for that. And of course everybody who's ever tinkered with electronics has probably used 555 timers. I have a couple in my parts bin. There is a couple of components that are also pretty common. You need a bit of Stripboard for this build, which I also have in my parts bin. The nice thing about this circuit compared to other 555 based circuits is that you can actually control the Autofire speed with a little potentiometer or a variable resistor, which is the same technically. And it has an LED that flashes when the Autofire is active. So that's pretty neat, and I think this is kind of, I love the old schoolness of this, and this is going to be a super reliable, super simple circuit to put in my joystick. I think I love to keep it old school. Maybe I'm going to add Arduino stuff later. There's so many options, but the moment I saw this, I instantly fell in love. So I'm just going to build this and maybe expand the joystick later. Maybe a little aside about the 64er magazine. My father used to have all the issues starting from like 1984, when the magazine was first published, I think. And we had many, many issues for many, many years up until the early 90s, when all the families switched to Amigas. But this is not the actual issue where the Autofire circuit is in. This is one of the ones that I still kept, thankfully. A Peeks and Pokes special issue. If you can ever get hold of this and understand German, I highly recommend this magazine. Just invaluable how much content there's in there, and there's type-in listings and hardware mods you can build yourself and things like that. All kinds of info about how the inner workings of the C64 go, things like that. I absolutely love these, so highly recommend these. There's also PDF versions online of these now, so you can probably find them if you search around the web. So my joystick, actually I made this out of some cheap knockoff arcade parts I got from Amazon. And this is actually a keybox, not a cash box, as I falsely advertised. I didn't realize it, but some eagle-eyed viewers instantly pointed that out to me, so I apologize for that. Oopsie. This is a keybox, not a cash box, but it's technically the same as a cash box, I guess. It's made of steel. We are going to have to drill some holes in this. But first of all, let's build the Autofire circuit itself. So I printed out the circuit or yeah, it's not a circuit diagram, it's a layout. I got a piece of stripboard that I'm going to cut to size. This is basically just a prototyping board with strips of copper that are connected. So these are connected in rows, basically. And I'm going to use a blade. How many rows do we actually need? 1, 2, 3, 4, 5. We need 7 rows. 1, 2, 3, 4. I think I'm going to leave one extra because we have a huge case. And you can usually just cut these a couple of times and then break them. There we go. You can, of course, use other methods to cut this in a more clean way, but I'm using this way because it works rather well and it's the fastest way in my experience. So this is what we're going to work with. The side with the copper is actually going to be used to solder the components. We're going to place the components from this side, which has no copper. But other than that, we are going to lay out the components exactly as in this, and we are going to connect the pins of the joystick and the pins that go to the C64 later. Yeah, the components are pretty standard stuff that you probably have in your parts bin. We need a 100 nanofarad small ceramic capacitor. We need a 10 microfarad larger capacitor. We need an LED. We need an 1N4148 diode, which is the most common type of diode that you can probably find these days. An NE555 timer chip, I have a couple of those. Couple of resistors, 220 ohms, 1 kilo ohm. And we need a 25K linear potentiometer or variable resistor. I have a 20K variable resistor potentiometer thingy that I salvaged from an old radio, I think, that I found in the street some time ago. This is a nice Alps one as well. So great brand part. This is going to last forever, probably. It's already old. I guess this is probably from the early 80s or something, but the radio was beyond all repair. It was just crushed. I don't think I want to go into much detail about how to actually solder this, because it's all pretty clearly laid out here. However, I am going to film everything so you can see how I do it, basically, without much explanation, and whenever I encounter something that's interesting or odd, I'm just going to report back. So yeah, let's do some soldering. This is a nice retro build. Oh, and we are going to use these offcuts, the legs from the components, as the bridges that we need for this later. So I'm going to hold on to these. Yeah, as you've seen, I put a socket in for the 555 timer. You can, of course, solder that directly to the stripboard if you want. I just prefer to use sockets for all ICs, basically, because they can break, and in case we break this or we made a connection in the wrong spot, we can still replace the 555 and save that. So here's where we at. looks pretty neat from this side, but the other side looks a bit messy. I tried to mark all the spots where we have to remove the trace or cut the trace. So I'm going to do that, I think with a small drill bit or with a knife or with a Dremel. I haven't decided yet. Probably the next step. I marked the spots where the connections to the outside world are going to be, which are on each side. We have a ground going through here. Of course, this is going to be hooked up between the joystick button and the actual output of the joystick. So yeah, this is pretty much it. We still have to wire up our potentiometer, which I'm going to just wire up with some wire. And we are going to wire up our LED, which I also want to have on the outside of the case. So I'm going to use wires to connect that as well. We are going to populate this after cutting the traces here. I want this to be accessible through some extra buttons. I'm not going to put a switch in here, but two smaller secondary fire buttons that actually trigger the auto fire. I'm not sure if anybody needs permanent auto fire these days. I don't. So I'm just going to wire up these switch connectors to a button, or to two buttons in this case, in the end. And I'm going to use this purple LED, I think. Put it on the outside of the joystick case in this little LED holder, which should be pretty awesome. And we obviously have to put this in the case before we can permanently fix this. Yeah, this is going to be super nice. So just some more wires to attach to this. We are going to try this outside the case at first. Could of course put pin headers on here and things like that if you want to make this a bit more elegant, but I'm just going to do it this way because I'm probably going to get away with this. I am at this point, probably should have done this earlier, I'm going to use a 3mm drill bit to try and drill out the cuts in the traces here. Yeah, that works reasonably well. That works really well, okay. And I don't want to drill through the stripboard here, just remove the copper layer. Pretty confident this is now an Autofire circuit. Just have to put the NE555 timer chip in, of course. Yeah, so this is what my circuit board looks like now. I made the cuts with my drill bit there. And as far as I can see, we should be good. There should be no shorts. Everything just looks pretty clean. Yeah, considering this is stripboard, soldering on this is not that easy if you don't want things to overlap and stuff like that. But I think it worked. I put one of the little jumper wires on the bottom side here, the one on the NE555. That's this one here. And of course, looking to it from the back side, everything is mirrored, kind of. So this should still be the correct spot. So I think we can temporarily hook up an LED to this. The long leg on the LED is the positive leg, the anode. And the shorter one is the cathode. So this should be technically correct, hopefully. Yeah, we are of course going to populate the spot for our timer with a little timer chip. And then the plan, I hope this works out, is to power this with my bench power supply and see what we get. And I'm going to hook up some buttons as well. And we should just have to feed in 5 volts basically from the computer side. We don't even have to connect the 5 volts on the joystick side, because this is meant to be hooked up between a joystick and a computer. So you have 2 DE9 connectors that connect between the joystick and the computer. But in this case, we are going to connect this internally in the joystick, so we don't really need the connection from the joystick side for the 5 volts. So I hooked up 4 wires for the switches actually, because we need 2 switches when this is finished. So I'm going to connect 2 switches. And I made the connections for the switches the ones that have these spade connectors, so we can just plug the switches in basically and test that out. I'm going to use these slightly smaller ones for that purpose. It shouldn't matter which side we connect to which pin. Yeah, that's good. Now we need a 5 volt source, and I'm going to use my bench power supply for that. So bench power supply is set up for 5 volts. I'm going to connect this to the voltage input. And we might see the LED flashing. Ground to the ground. That should be the ground. And this should be the 5 volts. Let's see what happens. Okay, we don't get anything. Let's see if our LED flashes. Nope. That's bad. Why is that? Oh, and it's actually drawing too much current, it seems. Let's switch this to amperes. Okay, that's 1.5 amps. There's a short somewhere. The good news is I probably resolved the issue. My drilled out bit here between pin 1 and that would be pin 8 of the NE555. There was a little bridge there still that I didn't fully drill out, so we produced a short. So worst case, we fried our 555, but I have plenty of those, so not to worry. We're just going to try again. Otherwise, the circuit looks good. I also measured some other bits of it, and there's no other shorts that don't belong there, I think, I hope. So we are going to put the 555 back in, which I removed. These are relatively sturdy, so hopefully it survives, I'm not sure. I'm going to give this more power now and see. Yay! And we actually have a blinking LED now. So I don't know how visible this is going to be on camera, but you can see the LED flashing there, and we should be able to control the speed. This is pretty slow. Let's see. Yay! Oh, and we can control it to very fast speed, actually, so that it barely lights up anymore. That's nice. Controllable autofire. Does the other button work too? Yes. That's exactly what I wanted to achieve. Yay, we made an Autofire circuit. And as I said, I'm not going to put a permanently on switch for this into my joystick. You can, of course, just hook up a switch that closes to this instead of the buttons, or additionally to the buttons maybe. You could do that as well. We made a controllable blinking light so far. I hope this is going to work as an Autofire circuit actually. We're looking at the signal directly on the LED now. Look at that. Okay, that's our Autofire signal in all its glory. That's how it's supposed to look. That's what the LED sees, and that's what our output is going to see. Very nice. Square wave. Yeah, whenever this is going to be pulled to ground, this is a fire. Let's change the speed. There we are. That's a bit faster. Nice. Okay, this seems to work absolutely fine. This is the potentiometer changing speed, basically. This is super clean. This is kind of amazing. Yeah, this is a convincing Autofire circuit. And I suppose my 20K instead of 25K potentiometer is going to do fine, judging by the speed of the LED. Yeah, 25K is what was specified in the circuit, but 20K should be super fine for this purpose. I guess it's time to put it in the case, actually. So let's remove the oscilloscope probes here. Yeah, in order to fit this into this, we are going to need some spots for the extra buttons. This, as I said in the previous video when I built this I'm going to use sitting in my lap while staring at the screen. And for that purpose it actually works pretty nicely. I think, as I'm primarily using these like this, I want the extra buttons somewhere like here or something like this. And I probably want the LED here and the potentiometer here or something, where it doesn't interfere. I'm going to rest my palms here. So this is completely out of the question. This is no-go. Yeah, we are going to put the buttons here somewhere, and the LED and the potentiometer here, I think. As I said, I'm building this to my specifications, to my needs. Feel free to do it differently than I do. Shouldn't be too close to the other button, I guess, but not too far away. Yeah, something like that. And then I can easily just switch to Autofire. I guess I want the LED somewhere like here. And we're just going to orient these in line with the key thing. I think that would be even better. So LED here, potentiometer here, something like that. That would be pretty nice, I guess. I think this is what I'm going to go with. And as for the connector, I am going to put another connector in here because we need plus 5 volts, which this cable, which came from a really very simple joystick, it doesn't have 5 volts. I found in my joysticks stash, I found this joystick extension cable, and you can actually, this has all the pins wired through. So what I'm going to do is to put one of these in here, a DE9 female socket, and that should go where our original joystick cable went, should be wired up to the correct pins on the existing wiring, and then we are going to use an extension cable as our actual joystick cable. This sits in here quite nicely actually, so it should be fine. And we have a detachable cable, which is super nice, of course. The only problem is that we need to cut out this shape out of the metal. First of all, we have to remove this cable, which I'm probably just going to cut off. Let's get this thing out here. There we go. Yeah, something like this. And then we are going to probably use some key files to get that. Probably that's going to be the first thing I do, because that's the most difficult one. And when I can fit this in there, I'm going to drill some holes to fit some screws to affix it. So I guess it's time to drill some holes and do some filing. I'm going to use my awl here to put some center marks on here so the drill doesn't slip. And we're going to have to use some drilling paste again. This drill bit is super dull. But we're going to be fine. And I'm just going to drill some pilot holes with this 3mm drill. Yeah, this DE9 connector hole is going to be the most fun by far. So let's just start with this. Hey, it fits. It's a bit at an angle, as is normal for my builds. I'm just going to drill some screw holes here to put some screws to completely mount this. There we go, that wasn't too bad. So for the potentiometer and the LED, I'm going to use a regular drill bit. This is going to be 8 millimeters, and the potentiometer is around 7, so I'm going to drill with a 6 millimeter bit and widen the hole as necessary. For these buttons, I'm going to go with a step drill. Okay, that didn't turn out too badly, so that's going to be nice. Okay, I cleaned this up reasonably well. Used some compressed air, some alcohol, some window cleaner. And now it's time to actually place some components. Yeah, let's mount everything. Yeah, for these buttons I actually ended up using some electrical tape around the parameter. I think that's what I'm going to do with these as well. They make a pretty good fit, but they actually turn a bit when you handle them, so I don't really like that. So to prevent that, I'm just putting a bit of electrical tape around the parameter. Yeah. Okay, nice. Pretty nice. So far, so good. Now for some screwing in of things. So this should just screw in from the bottom here. Removing this testing LED thing. And we're going to solder to this LED, to the purple one, later. Now for this thing, I'm going to heat shrink the heat shrink. That's just basically for protecting this against shorting out with the case or anything. And this goes here. And is actually screwed in from the top. There's obviously going to be some kind of knob that we put on there. I have yet to choose. But it's quite nice already. Okay. This is going to be nice. Let's see if our cable fits this actually. It should. Yay, perfect. Okay. So we're going to put some nuts on there. Okay, now that's not going anywhere. We could potentially wire up our LED. I'm going to put some heat shrink tubing over that, obviously, to our connections. And then we should be ready to connect our joystick connections back up. I'm not quite sure. Maybe I'm just going to cable tie this to this lock thing. That might be an easy way to keep this in place. And then we can just make our connections from here, which should reach. Yeah. Should be able to connect our buttons. And our LED connections can be much, much shorter than that. Quite nice. I'm going to put some insulation on here and cable tie it to this thing, because that's not going anywhere. Shall we do that? I guess so. Yeah, that's going to be pretty nice, I guess. I think that's what I'm going to do. So I'm just going to put some insulation, some electrical tape on this from the back side and affix it to this lock. I don't know if it's a good idea, but it is the spontaneous idea that I got. So I'm going to work with that for now. I'm just going to put some extra insulation on that as well. Yeah, this is kind of a hack thing to do. We could, of course, have drilled proper holes in the circuit board and make some proper standoffs and screw it down to the case, but I think this is a totally reasonable way of doing it. To the cable ties! Also, what kind of project doesn't use cable ties? So this needs some cable ties. Yeah, that's pretty good. So we can connect the joystick connections. There should be one red wire and one black wire for each one. That's our buttons connected. And this, of course, moves a bit with the lock. If we had a key, we could turn this, but I don't have a key, so it's not going to turn. And for the LED connections, I'm going to add some heat shrink tubing, but I'm going to definitely massively shorten these wires. So our grounds can basically just be connected together to one of the ground lugs. I think I'm just going to use the ground from this fire button, and I'm also going to use the fire connection. That is actually this wire from that, I guess. That should be pretty easy to do. The only thing that we really need to connect to here, from here, yeah, we have to connect this wire, which is the fire from the Autofire actually. And we have to connect the ground and the 5 volts. And then we're just going to have to hook up all the directions and the regular fire buttons. Now what remains to be done is to wire this up internally. We are going to connect pin 6, which is the pin for fire on the joystick, and pin 8, which is ground on the joystick. This side of our little circuit board we're going to wire up to our actually contacts on the joystick assembly, and we are going to wire this side up to the side with our connector. This is going to be the side on the computer. And yeah, we basically need to wire up an extra for pin 6 because there's a resistor in there, and otherwise our Autofire is not going to be transported to the computer, which would be a bummer. So yeah, that's basically how I'm going to do it. Let's see what I come up with. So I'm going to take these 2 wires, which are the ones that are supposed to be on the joystick side, and I'm just going to wire them up to one of these fire buttons, I think, because we have our pin 6 connection and our ground connection on those, and that should be absolutely fine for that. They're all connected together anyway. So yeah, let's do that. Yeah, so I soldered this onto the ground pin, and I'm going to solder this one onto the fire pin. Actually soldering directly to these spade connectors, which works fine. And I'm using some extra flux to make it easier to solder, which always helps if you're soldering to larger pieces of metal. So that's our connections for this side of the equation. The other ones are going to go here. Our fire connection is only going to go through our little PCB now. So we are not going to use the connection to here. And I'm probably going to extend these wires a tiny little bit. Yeah, and then I'm just going to connect everything up according to this, which in this case will be much easier because this is actually the way I look at the solder side of this connector now. Last time we had to kind of mirror it in our heads, but yeah, I've written on all the color coding. So this should be quite a lot of soldering, but pretty straightforward otherwise. So let's do this. I'm just going to use excessive amounts of heat shrink tubing, some patience and some soldering skills. that's all our connections made on the connector, I think. So yeah, this should be a joystick now, hopefully. So in theory, we should be able to test this now, I guess. So time for a test run. I think we made all the connections correctly. And maybe this even works. First try after assembly. Let's see. Okay, I set up my Amiga 1200 and look at this. It actually, the LED lights up. If I push normal fire buttons, it doesn't light up, just as it's supposed to be, and the autofire buttons actually activate the autofire. Yeah, the LED color looks pretty nice. I don't know if it translates well on camera, but yeah, that's promising. Let's see if the joystick works. I really hope this is going to completely work, hopefully. Let's try the Turrican test. As usual. Okay, let's see if the fire button starts the game. It does. That's a good sign. Okay. Yeah, we can move. We can jump. Does the autofire actually work? Yay, we fired. Okay, I died. I'm sorry. I'm a bit overexcited. Okay, autofire. Turning the fire ratio up. And you can... This is amazing. You can actually see the saturation. This is too fast. Can't even. But this is a good fire ratio. Nice. It works! It works! I'm obviously playing at a weird angle now. I should be able to actuate the fire button, the normal fire button, during holding the other one down. Yeah. So even if we make the autofire like a permanently switched on, this is super nice. Okay. Yeah, this totally and utterly works. And I think the placement of my fire buttons is also pretty nice. I like that. And we have the nice flashy LED each time the autofire is activated. Yes! And all with the little 555 timer and some additional components. Adjustable autofire! This thing utterly works, and the only thing that's really left to do is to add some kind of nice flashy knob to our adjustment here. Yeah, I like that. I kind of like that look. That looks good. Okay, finished product, I think. We need to do some cleaning up internally with the wiring. But other than that, this is a super nice joystick with the newly added fancy Autofire circuit. Yeah, I'm going to clean up the cables a bit and use a dab of hot glue here and there, but I'm probably not going to bore you with that. It is a working product that I made. Maybe this inspires you to do your own Autofire circuit. I can only say the 555 based circuit that I put in here is kind of amazing. Perfectly adjustable to whatever you need, whatever your game can handle. We can still use the normal fire button to hold that down for some extra weapons and things. I like the layout. Of course, you can do it differently if you prefer a different layout. You can also, we could add a permanent autofire switch, but I've never really used that stuff in joysticks I own that have pre-built-in autofire circuits. I think that's it for today. I hope you enjoyed this video. We created kind of a monster, but a useful one, and it's fully functional, working as I planned actually. Some things are a bit at an angle. I hope you do it better if you plan to build your own joystick. That's just my way of doing things, as you probably know if you are following this channel. Thank you for following this channel. Thank you for watching my videos. Thanks for subscribing. Thanks for your donations on Patreon and on the YouTube channel memberships page. Hope to see you again on this channel. I'm Jan Beta. See you next time. Bye. I'm just going to have to play some more Turrican with this new joystick.